for this video, new topic na tayo, second law of thermodynamics. Illustrated by, hanap tayo ng example sa nature kung saan nade-demonstrate ang second law of thermodynamics. Kung mahilig kayo sa coffee, then you would know, kahit hindi kayo mahilig sa coffee, you would know that a hot coffee would eventually turn cold. Okay, so may heat na nare-release. And then, for example, meron kayong dalawang gases. Una, separated sila. Yan. Eventually, magmimix sila. May disorder, maghalo-halo na sila. Yan ang mga examples ng second law of thermodynamics sa nature. Mag-isip pa kayo, maraming example sa room nyo, diba? Pag nagsimula kayo maayos yung room, maya-maya magulo na siya, yun, etc. Sa leaking of gases. For example, meron kang tank na may butas, eventually, yung gas sa loob, mag-leak out siya. Yung first law of thermodynamics, inaral natin nung past lectures, past lessons. The observation is that energy is conserved, but it does not give any restriction on the process direction. Important yung process direction. On the other hand, the second law of thermodynamics states that processes occur in a certain direction and not just in any direction. Now we move to the quality of energy. We use second law of thermodynamics to determine the quality and of the energy. Okay, may iba-iba siyang, yung energy, not all energy are created equal. Hindi pala created equal kasi hindi na-create yung energy, no? So, mali. Not all energy are equal. Merong quality sila. Okay? For example, yung work, it's readily transformed into other forms of energy. Yan, by elevation of weight, it can be transformed to potential energy. If we accelerate a mass, it can be transformed to kinetic. If we operate a generator, diba, it can be transformed to electrical energy. So, ano yung masasabi nyo sa work? Madami siyang potential uses and it's a high quality na energy. And the efficiency of conversion of these processes can be made to approach. Take note yung keyword approach, no? But never reach. Approach 100% by eliminating friction. Yun. Kalaban natin yung friction if we want a high efficiency na process. And si Joule, yung work niya also demonstrated that work is readily transformed to heat. Diba? Ano yung experiment ni Joule? Yung may stirrer na ganyan. So, yung work dyan, yung pag-stir, and then uminit yung laman ng vessel. So, ibig sabihin yung work nung sa stirring can be converted to heat. But the conversion of heat completely into work or into mechanical energy or electrical is not possible. Diba? So, hindi, yung heat, okay, kasi baka isipin nyo, may heat tayo, pwede nating gamitin 100% para maging work. So, it's not possible. Yan. So, makita nyo ba? Yung work, okay, pag nag-apply ako ng work dito sa stirrer, may heat na mapoproduce. That's conversion of work to heat. Pero yung opposite direction, nag-apply ako ng heat, not necessarily, diba, na iikot to. Okay? Therefore, anong masasabi nyo do sa heat versus work? Yung work, mas useful siya. High quality yan. Pero yung heat, intrinsically less useful siya and less valuable. Kasi kung ganun na lang din pala, ang dali na sana ng buhay natin kasi init-init dito sa Pilipinas, diba? Pero hindi lang ganun kasimple kasi yun. So, less valuable siya than an equal amount of work or mechanical or electrical energy. So, itong mga to, work, mechanical energy, electrical energy, high value, high quality type of energy sila. Pero yung heat, hindi masyado. Hindi siya ganun ka-useful. Tapos, while the conversion of work to heat can be achieved at a maximum of 100%, remember that's work to heat, ha? Yung pabaliktad, has been found to have a limit of 40%. But of course, as yung technology is improving, na-increase naman yan. Especially if sa mga small scale. Pero yung sa big scale, sa industrial scale, medyo limited tayo sa ganyan. Okay, so ito naman, video. Mag-share na lang ako ng ibang video para hindi tayo ma-copyright issue ni Google. Classical statements of the second law of thermodynamics. Okay, ito na yung mga statements ng second law of thermodynamics. Yung una, si Kelvin Planck. Sabi niya, it is impossible for any device that operates on a cycle to produce no effect other than the extraction of heat from a reservoir and the performance of an equivalent amount of work. So, na-imagine nyo ba? For example, meron kang cycle, meron kang cold, sige, ito muna yung hot reservoir, ito yung cold reservoir. So, impossible na meron kang machine dyan or engine na ang gagawin lang niya work. Wala na siyang ibang effect. Okay? I'm sorry. Ito, teka. Erase. Paano ba to? So, sabi ni Kelvin Planck, for example, meron kang hot reservoir. Okay? Meron kang device. Impossible daw yan. Yung mangyayari na yan na ang mangyayari lang ay i-extract na yung energy from the hot para i-convert completely to work. Ano yung nangyayari sa totoong buhay? Yan, in real life, IRL. So, laging may nadadump sa cold reservoir. Yan ang possible. Pero yung kanina na from hot, hindi yan. Impossible. Next is yung Clausius statement. It is impossible to construct a device that operates in a cycle and produces no effect than the transfer of heat from a lower temperature body to a higher one. Yan. Impossible to construct a device. So, ito sinasabi niya, hindi pwedeng mag-construct ng device na From a low, ayan. Ito naman babaliktad. From a cold reservoir, impossible daw to. Okay? Ano ang pwede? Ano ang pwede? Ano yung possible na scenario? So, from, ay, baliktad na naman. Ulit. Okay? Ito raw yung impossible. Hot, cold. Okay. So, hot, cold. Yan. Impossible daw yan. So, ano yung possible? Hot, cold. Meron kang application ng work. Yan. So, yan ang possible. Itong nasa left, impossible. Kuha. Ano pa? Ayan. Ito, sinasabi lang niya ito, impossible, no? Pero yung pabaliktad, possible. So, laging from a hotter to a cooler body. Yan. So, also tells us the impossibility of completing a cycle by heat transfer alone. Now, we define a heat engine, machines that operate in a thermodynamic cycle and do a certain amount of net positive work as a result of heat transfer from a high temperature body to a So, ano yung heat engine sa ating diagram? Ito ang heat engine. Yan. So, ang purpose na is to extract heat from a high temperature body and dump it to a cold temperature body while producing a net amount of positive work. Examples of heat engines: steam power plant, CARNOT engine, gas turbine, ganyan. Even yung nasa kotse nyo, nasa motor nyo, yan, engine yun. Yan, ito ang ating heat engine. So, from the high temperature reservoir, may QH, tapos part of the QH gagawing work net, then may matitirang QC na idadump sa low temperature reservoir. Characteristics of a heat engine. They receive heat from a high temperature source. Ano yung mga example nun? Pwedeng galing sa sun, pwedeng galing sa furnace na ang fuel ng furnace ay oil, pwedeng fuel ng furnace ay coal, or whatever, petroleum product, or pwedeng biomass, pwedeng damo, basta furnace. Pwedeng galing sa nuclear reactor, basta yun ang different sources of heat. They convert part of this heat to work. Okay? Yun nga. Usually, paano? Through a rotating shaft. Rotating shaft. Yan. And they reject the remaining waste heat to a low temperature. Anong example? Yung kapaligiran natin. Yan ay heat sink. Yan ang low temperature reservoir. So, yung atmosphere, rivers, lakes, at saka, lastly, heat engines, they operate on a cycle. Some definition, ano ba yung thermal energy reservoir? It's a hypothetical body with a large thermal energy capacity. Mass times specific heat that can supply or absorb infinite amount of energy as heat without undergoing any change in temperature. So, ito nga yun. Yan ang hypothetical body natin. It can supply finite amounts of heat, of energy, as heat without change in temperature. Example, Mali. Ito pala yon, yung cold pala ang ibig ko sabihin. Erase. Yung cold temperature, yun yung makaka-absorb pala. Absorb finite amount of heats without undergoing change in temperature. Ayan. So, examples, yung oceans, lakes, rivers, yun nga. Some definition, sabi na, working fluid. Okay, ano naman yung working fluid? Ito yung, siya yung carrier ng heat. Okay, fluid involved in heat engine to and from which it is being transferred while undergoing a cycle. So, siya yung carrier. Kasi, di ba, if ganyan yung cycle mo, ano yung nagdadala ng heat? So, yun yung working fluid. Okay? Ano yung pinaka-common na working fluid? Water. Kasi non-toxic, cheap, readily available. Of course, meron din gumagamit ng mercury, etc. Pero, of course, pag sinabing mercury, diba, toxic siya, kaya di siya masyado popular. Pinaka-popular is water. Yung air, isang example din yan ng working fluid. In fact, yun ang ginagamit ng mga combustion engine sa sasakyan. The fraction of heat input that is converted to the net work output, it is a measure of the performance of heat engine. Therefore, very important, yung thermal efficiency, equal siya sa work net over Q in, or yung Q na pinasok mo, total heat input. Okay, so please memorize this equation by heart. That is the thermal efficiency. Pero yung work net kasi, equal yan sa Q in minus Q out. So, replacing that in the equation, yan. So, ilabas lang yung 1 para maging ganyan ang equation. Important, absolute value signs are used to make the equations independent of the sign conventions for Q and W. Kasi may mga sign convention tayo, di ba? Pag yung heat pumasok sa system, positive. Pag lumabas, negative. Pag yung work done on the system, positive. Pag work done by the system, negative. So, always keep that in mind, yung sign convention natin. What is a CARNOT engine? Okay, so it's a heat engine operating in a completely reversible manner. It operates between two heat reservoirs in such a way that all heat is transferred at the constant temperature of the hot reservoir and all heat is rejected to the constant temperature of the cold reservoir. So, meron siyang 4 steps. Dalawang reversible adiabatic and dalawang reversible and isothermal. It can be operated in a reverse. Pag ni-reverse mo, magiging na siyang refrigeration cycle. Okay? And it's the most efficient cycle. It was named after Nicholas Leonard Sadi Carnot, who stated the second law of thermodynamics in 1824. He's a French engineer. Yeah. So, these are the 4 steps of a Carnot cycle. Reversible adiabatic process. Ano nangyayari sa working fluid? Temperature of working fluid increases from low temperature to the high temperature reservoir. Next na step ay yung reversible isothermal process. Heat is transferred from the high temperature reservoir. Reversible adiabatic process, yung temperature ng working fluid decreases from the high temperature reservoir to the low temperature reservoir. Finally, reversible isothermal process, heat is transferred to or from the low temperature reservoir. Yan. Okay. So, para mas maintindihan natin yon, mas maganda may diagram. Okay. Step 1, yung temperature ng working fluid, pinareho. Okay? Tumaas papunta sa temperature. From the temperature, ito kasing TC yung temperature ng low temperature. Ito T hot. Temperature ng hot reservoir. So, yung first step yan. Second step, isothermal na nag-absorb siya ng heat. Okay? Second step, bumaba. Okay, bumaba yung temperature. Third step yun. Fourth step, isothermal na nag-dump siya ng heat. Okay? So, yun yung lahat ng step na yan reversible. Okay? So, by the way, dito sa first step, adiabatic yan. Sa third step, adiabatic yan. Q equal to 0. Prepositions regarding the efficiency of the Carnot cycle. Number 1. It is impossible to construct an engine that operates between two given reservoirs that is more efficient than a reversible engine. So, pinaka-efficient na engine ay reversible engine, which is yung Carnot engine. Wala nang mas i-efficient pa dyan. All engines that operate on the Carnot cycle between two given constant temperature reservoirs have the same efficiency. For example, may dalawa pang cycle. Okay? Ito may TH. Ito may TC. Ito may TB. May TD. Equal siya sa TH. Ito equal sa TC. Therefore, pareho sila ng efficiency. Efficiency nito nasa left equal sa efficiency nung nasa right. Okay? Dahil pareho sa same sila. Same temperature reservoir. As long as Carnot cycle. The thermal efficiency of a Carnot engine relies on temperature levels. And important to, not on the working substance. Hindi siya dependent sa working substance. Ano siya dependent? Sa temperature level. Pakitandaan. Okay? Not dependent on the working substance. Dependent lang sa temperature level. Since the efficiency of the Carnot cycle is independent of the working substance, kaya, tinan mo, yung formula ng efficiency natin, meron ka bang nakikita working substance dyan? Wala. Wala kang nakikita. Ano nakikita mo? Q lang. Tapos yung Q, pwede mong i-relate sa temperature. In fact, yan. Pwede mo siyang i-relate sa temperature so that yung efficiency ng Carnot engine mo ay pwede ring i-write in terms of temperature. Kasi nga, dependent lang siya sa temperature. Absolute yan absolute temperature. So, wala kang makikitang working substance. Okay? Yung example ay sa next video na.